Hello and welcome to this instructional video on the circuit breaker calculator. It's among a suite of 10 tools that are designed to allow a competent electrical engineer to determine the severity of an arc flash incident. My name's Mike Frayne and I'm the creator of the European Arc Guide and also the author of the book The European Arc Flash Guide. To understand the risks of the arc flash hazard, you need to be able to calculate the incident energy level at the worker. Prediction is fundamental to the whole risk assessment approach because, as they say, if you can't measure it, you can't manage it. In using these hazard severity tools to calculate the incident energy at the point of work, this will provide the bedrock of information from which decisions can be made in respect of safely managing the risk. Once you can identify and quantify the hazard, you can decide if work can proceed and if so, what preventative or protective measures need to be in place. Once this is completed, you can continue to manage the risk by using the Prevent, Process and Protect chapters from the guidebook shown here. To access the circuit breaker calculator, select the Calculators tab and then Circuit Breaker. If you select Expand or Collapse, you'll be able to provide preset configurations which will reduce the need for repeated data entry where the same conditions are being used in several calculations. Second option is to click on Circuit Breaker Instructions, and this will give you access to comprehensive guidance on how to use a calculator. The first field is Electrode Configuration, and you can learn all about configurations from the instructions and more detailed in the guidebook. As can be seen in the diagram, the configurations are VCB, VCBB, HCB, VOA and HOA, and basically denote vertical or horizontal conductors in air or constrained in a box. We'll use VCBB for our example, which denotes vertical conductors that are terminated into an insulating barrier. The next field is a system three-phase line voltage, and if you click on the question mark you can see that this tool is valid for 208 volts up to 1000 volts. We're going to use a 400 volts, which is a usual LV system distribution voltage used throughout Europe. In the case of this calculator, a realistic determination of the prospective short circuit current at the equipment terminals will be required. There is a prospective short circuit current calculator available with the ARC Guide. We'll use a short circuit current of 25 kiloamps, which is typical of what might be available on the secondary of a ubiquitous 1000 volt transformer in industry. Next, we have the conductor gap distance, which may be the distance between bus bars, equipment terminals or cable conductors, so the figure that we'll use in this case is 25 millimeters. In the next field, we have the working distance, which can vary with the task to be performed, but in this case the figure is going to be 600 millimeters, which is a reasonable working distance for operating low voltage switchgear. There's much information about distance in the guide, as the relationship between distance and severity is exponential, meaning large changes in incident energy for small changes in distance. For the sake of simplicity, there are no enclosure dimensions with this calculator, bearing in mind that the main purpose is to discover the instantaneous tripping point where the incident energy can fluctuate between low and very high levels for very small increments of arcing current. In both cases, the results will be conservative, so a more accurate figure can be obtained if you use the incident energy calculator where enclosure dimensions can be entered. All the remaining fields contain information about the upstream circuit breaker that will hopefully trip quickly for arcing faults and therefore keep the incident energy as low as possible. The case that we'll use here is a 1600 amp circuit breaker with an instantaneous pickup level of 10. The next box is a check to make sure that the instantaneous pickup is switched on. We've checked on the circuit breaker settings and it is switched on, so we'll say yes. The remaining fields all display the circuit breakers that fit the criteria on which the calculator is based. That is, a fault that is picked up in the instantaneous zone will clear in less than 80 milliseconds, and the instantaneous clearance curve will be no more than 25% of the setting. If the circuit breaker is not listed, then you can still validate it in the setting selection as long as it fits the criteria given here and also in the instructions. The make of our circuit breaker is a Doman Smith ACB and the model is a Z2 1600 as shown, and its integral relay as an AGR 11BL GL. Finally, the frame size is 1600 amps. If we press the submit button, then you'll see that there's a very high level of instant energy and the arc flash boundary is nearly 6 meters. The reason is that the calculated arcing current is not cleared instantaneously and the calculator applies a maximum 2-second disconnection time. The advantage of the calculator is to be able to see how alternative settings can affect instant energy. By reducing the instantaneous pickup from 10 times to 8 times current rating and submit it again, the incident energy and the arc flash boundary is massively reduced, as you can see here. So what just happened? As you can see from the time current curve for the breaker, the arcing current will have had to be above the setting of 10 times, which is 16,000 amps, plus tolerances. What we did was to reduce the instantaneous pickup to 8 times or 12,800 amps, in which case the arcing current will disconnect instantaneously. And as you can see, this is well within the 80 millisecond clearance tolerance. So what's the significance? Well, at a setting of 10, we're looking at the likelihood of destruction of the equipment concerned, loss of critical supplies for a long period, and in some countries a duty to report the event to the authorities as a dangerous occurrence. At a setting of 8 times, there's a likelihood of minor but repairable equipment damage. The imagination can work out the differences in injury. Finally, the result can be stored by pressing the Store Instant Energy button, and the result can be exported, printed, or used in a dynamic risk assessment that is provided with the guide. As a brief glimpse of the form, we click on Calculators and there is an option, as can be seen, for risk assessment. This opens the form, which as you can see is sectionalised for Predict, Prevent, Process and Protect. By selecting the circuit breaker checkbox, this will automatically fill in the first part of the Predict section. This dynamic risk assessment checklist form will allow the user to systematically go through the 4P steps and consider the actions one by one. You can either complete the form online or download a Word document which can be custom edited for your needs. I do hope finally that you enjoy using the calculator in the field, perhaps on your phone or tablet or PC, and that you find that this guide to be a valuable resource to discover and manage dangerous levels of instant energy in the workplace, and therefore ensure the safety of electrical workers. Thank you for your time.